All right, today we're going to be talking about finding inverses of relations or inverses of functions. We're going to do both. The relations is really easy. We actually talked about it back in chapter 2 a little bit, real easy. The function's a little more difficult, but not too bad. And then if we're given two functions, we need to be able to tell whether or not they are inverses of each other. All right, so let's talk about this. Inverse relations, first and foremost. This is the easy one. All we're going to do is take a, b, and we're going to switch it to ba. So a and b are considered inverses if 1, 5 gives us 5, 1, 2, 6 gives us 6, 2, and 3, 7 gives us 7, 3. Very simple there. All right, so here's our ordered pair, 1, 3, 6, 3, 6, 0, and 1, 0. Find the inverse. So all we're going to do is flip them around. So we have 3, 1, 3, 6, 0, 6, and 0, 1. Now let's look at how the graphs go. Notice this line here, this dotted line, y equals x line. Y equals 1x plus 0 if you want to write it in full slope-intercept form. But we have these two boxes, and look that they are symmetric to that line. They can be flipped over that line to find the other one. All inverses will act like that. This dotted line here is the symmetric line for inverses. All right, so property of inverses. F and F negative 1 are considered inverses. That's the symbol for it, F to the negative first power. They are only inverses if for 1, 1 equals the other. So what does that mean? Well, what we end up doing to go ahead and solve for inverses is we go ahead and switch x and y. So remember, this is a y value, this is an x value. So if we go ahead and we switch them, then we can go ahead and find out the new value, the new inverse. So let's talk about that. So here we have this inverse, f of x equals negative 1/2 x plus 1. So what we're going to do is we're going to swap the y here and the x. So we're going to flip them. So now it becomes, so here's the original one, it's just y as opposed to f of x. And then we're going to change y and x around. So it's x equals negative 1/2 y plus 1. Now we're going to solve for this y. Of course, we don't like fractions, so we need to go ahead and get rid of that. To get rid of that, we're going to multiply everything by the denominator. If there's more than one fraction, we multiply by common denominators. So I'm going to multiply everything by negative 2. So this is negative 2x. That becomes just y, and that becomes negative 2. And now we just solve for y. We're going to add 2 to both sides, and then just flip it around. So the inverse is negative 2x plus 2. Now, again, we're going to graph these, and you notice that they are symmetric to each other according to that axis. How do we know if things are inverses? Well, that's the composite function that we did yesterday. If the f of g of x equals x and the g of f of x also equals x, then they're inverses. So here we have two different f of x and g of x, and are they inverses? Obviously, one easy way to do it is just to take one of them and find the inverse and compare it. You could go ahead and do that. But let's do it using the f of g of x. Now remember, what we're going to do is we're going to take this equation and put it in for x. So the f, we're going to put the 4/3 in for the x. Now notice here, those are inverses, those are reciprocals of each other, so we're going to cancel them out. So it's just 1x plus 6 minus 6, because 3/4 of 8 is just 6. And notice we just get x. We want to do the same thing over here. And we'll have to cross multiply and then distribute this here. And we get x plus minus 8 plus 8, and that just gives me x. So these are considered inverses because they just got x. If they get anything else, x plus 2, 3x, whatever it is, they're not inverses. Try it one more time. Here with a fraction. So the first one is 3, parenthesis, put this fraction in, plus 1. Those 3's cancel, x minus 1 plus 1. Well, those cancel, leaving me just x. And over here, the plus 1 and minus 1 cancel, leaving me 3x divided by 3, or just x. So they are inverses. And that's what I have for you today.